two very common scenarios that we get when we're dealing with the mixtures chapter are the mixing of two or more solutions to get a resultant solution, and the mixing of two or more alloys that contain, alloys that are a combination of metals, and these alloys are mixed to get a new resultant alloy. Here is an example. Two alloys of A and B which contain A and B in the ratios 2:3 and 4:1 respectively are to be melted together to get an alloy with equal parts A and B. In what ratio should the two alloys be taken? A and B are the metals. Using these two metals, we already have two different alloys. The ratios are 2:3 and 4:1. I want to mix these two alloys in a particular ratio so as to get a final a third alloy, which is A is to be equal to 1:1, equal parts A and B. How do I do this? Can I use the number line? The answer is yes. The thing to note here is your data is given in the form component 1 is to component 2. Component 1 is to component 2. Finally, what you need also, same format. All you need to do is, you need to convert this to component 1 by total. So for every two parts of A, two parts of A are contained in 5 parts of the alloy. 4 parts of A are contained in 5 parts of the alloy. What do we finally want? We want 1 part of A in every 2 parts of the alloy. Now you can also do B by total instead, but whatever you're doing, use the same component in all the 3 cases. So you can also do 3 by 5, 1 by 5 giving 1 by 2. Doesn't matter. Now after you made this conversion, you can just put it on the number line. The rate 1 is 2 by 5, the rate 2 is 4 by 5, and what we're trying to get is 1 by 2, right? Now, the second thing to note in this particular area is, don't waste your time subtracting 1 by 2 minus 2 by 5, 4 by 5 minus 1 by 2. The ratio of distance is what we want, not the actual distances. And this ratio remains unchanged when we multiply all of the numbers with a common constant. And what constant are we going to use? We're going to use the LCM of all the denominators. So you're going to do into 10, into 10, into 10. So when you do that, you will get the numbers 4, 5 and 8. Now you would notice that instead, if I had converted everything to percentages, I would have gotten 40%, 50% and 80%, right? Same ratio. Ratio is not going to change. The ratio is now 1:3. The distance ratio is 1:3. So clearly the quantity ratio has to be 3:1. And that's basically the answer. Alloy 1 and alloy 2 have to be taken in the ratio 3:1 to get a final third alloy which contains A and B in the ratio 1:1. Two alloys P and Q contain copper and tin in the ratio 1:2 and 5:7. If you mix P and Q in equal quantities, what would be the ratio of copper and tin in the resultant alloy? Now, just like we did a little earlier in the chapter, what I've done is I have flipped the known and the unknown. Now the mixing ratio is known. The mixing ratio is known. What is the rate of the mixture? That is the unknown. Let's see what can be done. Can we still use the number line? Yes. What we have to do is we have to take this 1 by 2 would become 1 by 3. 1 part of P for every 3 parts of the alloy, and this would become 5 by 12, right? 5:7 would become 5 by 12. So 1 by 3 and 5 by 12 are the two rates, and they are mixed in equal quantities. That's a 1:1. The flipped distance ratio would also be 1:1. So I'm basically trying to find the midpoint of 1 by 3 and 5 by 12. Now I could rewrite 1 by 3 as 4 by 12. And so basically what you have in between should be 4.5 by 12, which I'm going to rewrite as 9 by 24. 4.5 by 12 would become 9 by 24. Again, I can take out 3 from this. That would become 3 by 8. So the quantity, the rate for the resultant alloy, which should be copper by total, is 3 by 8, which means copper to tin would become 3:5. This is what you would do if you use the number line, but you don't necessarily have to use the number line when you have a known mixing ratio. Like if the given numbers are favorable, it might be easier to do something else. Let's see that. All right, same question. Look at it this way. You're mixing them in equal quantities, right? How about we take equal number of kilograms of alloys P and Q? You will see that 1:2 means the sum of the terms in the ratio is 3 parts, and 5:7 would be 12 parts. And what is the LCM of 3 and 12? That would be 12. So let's just take 12 kgs of P and 12 kgs of Q. This would give you 4 copper, 8 tin. This would be 5 copper, 7 tin. You just add it up, you'll get 9 copper, 15 tin. Simplify that, here the ratio 3:5. Oftentimes it's easier to simply get a nice little LCM thing going on and just add it up rather than take the number line when you have a known mixing ratio and you're trying to find what the resultant looks like. Now the previous example was we knew what the resultant alloy looked like, we didn't know the mixing ratio. In those cases, it is definitely better to take the number line.